Good morning, student. Today we are going to learn about CMOS clocked SR latch. After the completion of today's session, you are able to draw the clocked SR latch using CMOS and explain the operation of clocked SR latch using CMOS. So, clocked SR latch. Let's go to the logic diagram. So this one is the logic diagram. It consists of 2 NOR gate and 2 AND gate. Okay. So this part is the SR latch part. Okay. The same operation that we discussed in the previous class. This one is the extra part present in clocked SR latch. So here this part is required to give the clock signal to this SR latch. Okay. So here we give clock signal to this circuit. So the difference is that the circuit responses depend upon this clock signal. So when the clock is equal to 0, the input signal have no influence upon the circuit response. Okay. If it is 0, then the output of this 2 AND gate are also 0. So there is no control upon the circuit response. Then the output of this 2 NOR gates hold the previous state. Okay. But when the clock signal is 1, then the AND gate allows the input to enter into the circuit, and as per that input signal, here we get our output. Okay. So here the clock signal is the main signal whom the signal control the whole circuit responses. Okay. This is the truth table. Here you can see when the clock is 0, it hold the previous state or previous values. But when the clock is 1, the circuit is operated similar to SR latch. So when 0 0 is given, the output hold the previous state. Then when 0 1 is given, output is 0 1, means reset operation. Then when the input is 1 and 0, the output is also 1 and 0, which is a set operation. And when 1 1 is given, it is a not allowed condition because the output is 0 0. So here you can see this one S and R. Here the input signal is given, and only for this duration the clock signal is high, and during clock equal to 1, as per the input given, we get our output. But when the clock signal is 0, at that time whatever may be the input is, but the output hold the previous state. Here you can see, one second. Here see, it hold the previous state. It continues up to another positive clock pulses given. Okay. So this one is the point where a positive clock pulse is given to the SR circuit. Okay. Then accordingly in this duration, the output we get according to the input given. But after the end of this pulse, again CK is 0. So because of that, it holds the previous state until it again 1 CK equal to 1. Okay. So it is the SR latch using CMOS. So here the circuit looks very complicated. Okay. So this one is the S input, this one is the R input. Then here it one is the Q bar, here it one is the Q, and here this one is the Q input and here it is the Q bar input. So Q bar output connected with the Q bar input of NAND gate where the input R is given, and the output Q is connected with the input Q of the NAND gate where S is given. So here the PMOS connected in parallel. Then see here another thing I forgot to tell you. Here we can find out the output equation. How? So this one is a AND gate, so at the output of the AND gate we get S into Ck, here R into Ck. Okay, then this S into Ck given as input to the NOR gate, and to another input Q is given. So at the output we get S into Ck plus Q whole complement. Like here to another input we give Q bar, so R into Ck plus Q bar whole complement. So this is the equation. Using this equation we draw this diagram. So here it is very difficult to understand this diagram. For better understanding we have to draw it step by step. So let's draw the SR flip-flop using CMOS. So this one is the logic diagram. Here is the two output equation, that is Q bar equal to S into K plus Q whole complement. To this AND gate S and Ck are the input, and to this AND gate R into Ck is the input. So at the output we get R into Ck, and here at the output we get S into Ck, and S into Ck given as input to this NOR gate, and to the other input Q is given. Here in this NOR gate R into Ck is given as one input, and to the other input Q bar is given. So these are the output equation. In this equation dot and plus both operations are used. So for dot operation PMOS connected in parallel and NMOS connected in series. For plus operation PMOS is connected in series and NMOS is connected in parallel. So let's draw the diagram. First we draw the first equation. So S into Ck. So for PMOS they are connected in parallel. Ck, and then Q is connected in series. So the PMOS part is complete. Then we draw the NMOS part. For NMOS S into Ck connected in series. So here is the input S and this one is the Ck. Okay, and then Q is connected with them in parallel. So this part is over, and here is the ground, here is the VDD, and here we take the output line, and this one is the Q, so we connect it, and this one is the Q. Then we draw this equation. So similarly R and Ck are connected in parallel and the Q bar is connected in series. Okay, so upper part is complete. Then lower part, here the R into CK means they are connected in series, and the Q bar is connected in parallel with them. Then here is the ground, this one is the input R, and this one is the Q bar. So this one is the Q bar, and here we take the output. Okay, so the output of this circuit is connected with the input of this circuit. So here we connect the output with the input of this circuit, then here it is connected to the input of this circuit. Okay, so this one is the clock. Here we commonly give CK to both the transistor. Then here is the VDD. Okay, so the circuit is complete. So this is all about clocked SR latch. Thank you.